Closer to the poles of the earth you go, or ascend heights, the temperature turns low. 10,000 years ago, the world was colder than it is today, Britain immersed in snow. Glaciation changed the face of the countryside to become more like the earth we know. Working slowly, giant hunks of ice cut and slice, then push aside turf and stone. Signs say at the time of the ice age, a third of the earth's surface totally snowed over. Then the Fahrenheit rose, polar caps and ice flows capsized and shrank in size loads. Today the only glaciers remain on high latitude or low altitude terrain, so though only a tenth of the globe's glaciated, there's occasional formations close to the equator. See the way that they're made in this how-to guide? Snowflakes accumulate in mountainsides. The weight creates pressure, making a firm and dense substance that's termed by the name of firn. If the ice stays frozen as snow falls, then it snowballs, grows and grows more. And as the mass increases, gradually gravity grabs massive pieces and releases them. Woe betide anything in the way as they slowly slide lower and erode it away. With an amazing grace, glaciers patiently change the landscape on a grand scale. Glaciers, how long will they stay here? Glaciers, how long will they stay here? Two major stages make up glacial formation, and they're named accumulation and ablation. Accumulation happens in the winter, it gets bigger, while ablation is the inverse. It shrinks year to year, every summer then returns, and that's the basic annual changes that happen to a glacier. But on a grander time scale, the average size fails to remain the same, it changes at a snail's pace. Now I don't want to get too technical, so let me just explain the basics and then I'll change the subject. If you take away ablation from accumulation, then the data you remain with is the glacial budget. If the figure's bigger than zero, it's advancing, but if it's less, then it's a negative regime. The level will decrease until everything retreats, and all we're left with is a petty little piece of what it used to be. Experts agree that greenhouse gas such as CFCs mean the atmosphere's heat's increasing, leading to deeper seas, the decline in ice causing rising tides on shorelines worldwide. Glaciers.